Question 284. Let f be a twice the differentiable function for all x and its derivative is given by this. Which of the following is true? Following statement is true. Answer choices mention about relative maximum, decreasing, point of inflection, concave down, right? So basically we have the first derivative test and concavity test, right? Here we have a first derivative, so let's find the second derivative from this first derivative. So second derivative is equal to, here first derivative is exponential times 2x minus 1 squared, right? So we're going to have to apply the product rule to find the derivative. Derivative of e to the negative x, that's negative e to the negative x. And we have 2x minus 1 squared plus, leave this function alone and find the derivative of 2x minus 1 squared. That's power rule 2x minus 1 times derivative of 2x minus 1, that's 2 by chain rule, right? So f double prime is equal to, here we have the same factors, e to the negative x, e to the negative x, and 2x minus 1, 2x minus 1, right? And with this negative, I'm going to factor negative e to the negative x, 2x minus 1, and inside here we have 2x minus 1 squared, right? So we must have one more 2x minus 1 minus, since we took out minus here, this must be minus, right? And e to the negative x, it's right here. 2x minus 1 is right here. So 2 times 2, that's 4, right? So let's simplify this. It's a negative e to the negative x. We have 2x minus 1. This one, 2x minus 1 minus 4, that's 2x minus 5, right? So let's test first the derivative test and concavity test. Okay, here we have x number line. Remember, exponential is always positive, right? This exponential is always positive, never be equal to 0. So second derivative is equal to 0 when x is 1/2 and x is 5/2, right? Here we have a first derivative. First derivative is equal to 0 when x is equal to 1/2 only, right? So I'm going to write 1/2. Here 5/2. Okay, this is first derivative. Here we have 3 intervals to test second derivative, right? But if we look at answer choices, they're all talking about at x equal 1/2, right? Less than 1/2, equal to 1/2, greater than 1/2. So we don't have to worry about this value, this 5/2, right? Okay. So let's look at first the derivative test first. Here, exponential is always positive, right? And this is 2x minus 1 squared. If we have a square, this is always positive, right? Except for x is equal to 1/2, of course. Does that make sense? So f prime is always positive here, right? Now let's look at second derivative. It's right here. This is always positive. I'm gonna substitute 0 for x. So 0 here, 0 here. Then what happens is that we have a negative here, -1, negative, -5, negative. 3 negatives are multiplied together, right? So here we have a negative. So far so good. Now substitute any value between 1/2 and 5/2. Let's substitute 1. I'm going to substitute 1 here. Then what I have here is If x is 1, oops, 1, 1, then 2 minus 1, that's positive. 2 minus 5, that's negative. So negative times negative. This is always positive, remember. So we have 1 negative only. Positive, positive. I'm sorry, this is negative. Positive, positive. This is negative, right? So we have 2 negatives are multiplied together. Then that's going to be positive here. So far, so good. So let's look at answer choices now. F has a relative maximum at x equal 1/2. That's not true, right? In order to have a relative maximum, the derivative has to change from positive to negative, right? It's a positive. So A is not true. B, F is a decreasing? No, right? Since f prime is a positive here, f is increasing, right? Not true. C, f has a point of inflection at x equal 1/2. When does f have a point of inflection? Where f double prime changes its sign from positive to negative or negative to positive, right? Here, f double prime changes the sign from negative to positive at x equal 1/2, right? So we do have a point of inflection at x equal 1/2. So C is true. That's the answer. Answer choice D. F is concave down for x is greater than 1/2. When x is greater than 1/2, f double prime is a positive, right? It's concave up, right? Concave up here, down here. So this is not true. So the answer is C. Question 286. The function y is given by this. On which of the following intervals is the graph of y both increasing and concave down? Okay, graph of y is increasing when y prime is positive, and it is concave down when y double prime is negative, right? So we're going to have to find first the derivative and second derivative of the function y. So first the derivative first. First the derivative is 12x² minus 6x minus 6, right? And we're going to find the critical point. Set that is equal to 0. So let's factor 6. 2x² minus x minus 1 is equal to 0, right? So 6, we have 2x, x. Here we must have 1 minus here plus here, right? So that 2x times negative 1 minus 2x, 1 plus x, that's plus 1x. So minus 2x plus 1x minus x, right? So that is equal to 0. So critical points are x is equal to negative 1/2 and x is equal to 1. Okay, now let's find the second derivative. Second derivative is here. From this equation, derivative of this, that's 24x. Derivative of minus 6x, that's minus 6. So set that is equal to 0. So 24x is equal to 6. Then x is 6/24, which is equal to 1/4, right? So we're going to do the test. First, derivative test and concavity test. So let's draw the line here. So this is number line x. Here we have negative 1/2, positive 1/4, positive 1, right? So write negative 1/2, positive 1/4, and 1 here. At these two values, at these two critical points, we're gonna test apple prime, right? So first the derivative test here. At 1/4, x is equal to 1/4, we're going to do the concavity test. So second derivative here. So far so good. Now let's substitute the one value in this interval. Oops. So we're going to substitute -1, okay? Here, let's plug in -1 here, -1 here. That's negative. That's negative, right? Negative times negative gives us positive here, right? Now let's substitute 0. Okay, 0 here, 0 here. That's a positive, negative. Positive times negative. Here we have a negative. If we substitute 2, oops. Let's substitute 2 here. Then that's going to be positive times a positive. Here we have a positive, right? So far so good. Now let's do the second concavity test. So we're going to substitute, let's say, any value less than 1/4. I guess 0. 0. So we're going to substitute 0 here. Not here. The second derivative. So 0 here. Then second derivative is -6. Negative here, right? If we substitute 1, then 24 minus 6, that's going to be positive here, right? So we're done here. We're looking for the interval where the graph of y both increasing in this interval, right? In this interval right here, where apple prime is positive, and it has to be concave down, right? Concave down. It is concave down when second derivative is negative, right? So in this interval, negative from here to here, right? Since apple double prime is negative here, right? So both increasing and concave down, it's gonna be this region right here. Oops, excuse me. Oops. Okay, so it's gonna have to be this region right here, right? So where that's the interval where x is less than 1/2. That's the only reason. Only the interval. So the answer must be A, right? Question 289. What are the values of m and n so that this function will have a point of inflection at 2, -12? So this function y has a point of inflection at this point, right? If we graph this function roughly, let's say here's x-axis, here's y-axis, and 2, -12, let's say this is -12, and here we have a point of inflection, and this is polynomial function, right? So it'll be like concave down, concave up, roughly something like this, right? So this is our POI, point of inflection, right? At this point right here, y double prime has to be equal to 0, right? And also this 2, -12 is on the graph of y, right? So we're going to find the second derivative first. So y prime is equal to 3mx squared minus 2nx. Second derivative, 6mx minus 2n, right? So when x is equal to 2 and y is equal, well, we don't have to worry about y. When x is equal to 2, the second derivative must be equal to 0. At this point, second derivative is equal to 0. So set that is equal to 0. Oops. Set that is equal to, I'm sorry. I need a black, equal to 0. Okay, so 12m minus 2n is equal to 0, right? That's one equation we have. And also remember, this coordinate is on this curve, right? Curve of y, right? So when x is equal to 2, y must be equal to negative 12. So we're going to substitute 2 here, negative 12 for y. So negative 12 is equal to m times 2 cubed, that's 8m, minus n times 2 squared, minus 4n, plus 4, right? So negative 16 is equal to 8m minus 4n. It's all divisible by 4, right? Divided by 4, negative 4, divided by 4, 2m, divided by 4 minus n. So we have second equation. Negative 4 is equal to 2m minus n. Here, the first equation also divisible by 2. So 6m, just n, right? So we can say that n is equal to 6m. And we're going to substitute 6m for n right here. So negative 4 is equal to 2m minus 6m. So negative 4 is equal to negative 4m. Then m is equal to 1, right? So if m is equal to 1, what's n? N must be equal to 6, right? So m is equal to 1, n is equal to 6. So the answer must be A, right? Question 292. Let f be a twice differentiable function, but the graph of f has no point of inflection. If f of negative 1 is equal to f prime negative 1 is equal to negative 2, and f double prime negative 1 is equal to 1, which of the following could not be the value of f of 0? Using these informations right here, let's draw the graph of f roughly. Here we have x-axis. Here we have y-axis. Let's say this is y-axis. So let's say this value is negative 1, this value is 2. So graph passes through negative 1, 2, right? Here, f prime negative 1 is equal to negative 2. That means slope of tangent line at this point is negative 2. Function has to decrease, right? And when x is negative 1, second derivative is positive 1, which means the graph of f is concave up, right? Decreasing, concave up. So roughly it could be like that, right? So let's say this is f of x, and here we have tangent line like that. Slope of this tangent line is negative 2. Okay, when function f is concave up, tangent line is always underestimate the function f of x, right? This linear approximation is always underestimate. Okay, what if f is concave down like this? Then this tangent line or linear approximation is always overestimate, right? Does that make sense? Let's say this value is a, right? If we want to approximate the function f of x at this point right here, the actual function value is right here, but using this tangent line, it'll give us this value right here, right? So this approximation is overestimated. Does that make sense? Okay, so let's erase all this. So when function is concave up, linear approximation is underestimate. When function is concave down, Linear approximation is always overestimated. So far so good? Okay. So, which of the following could not be the value of f of 0? This value, right? F of 0. When we use tangent line, this tangent line has to be less than the function value, right? Well, reverse, this function value when x is equal to 0 must be greater than this value, right? Does that make sense? So let's find the equation of this tangent line. Here, slope is -2 and this point is -1, 2, right? So using point slope form, y minus y1 is equal to slope x minus x1, so x plus 1, right? So y minus 2 is equal to -2x minus 2. So substitute 0 for x, right? Then what is y? Y minus 2 is equal to -2, so y is equal to 0, right? Well, actually this value is equal to 0. Does that make sense? So f of 0, which is this value right here, must be greater than 0, right? It could be 1, it could be 2, it could be 3, but it cannot be 0 because this function value must be greater than 0, right? So the answer must be A. Does that make sense? Question 296. Suppose the function f is twice differentiable and the table above gives the selected values of f prime, and f double prime. Which of the following about the graph of f at x equal -1 is true? Here we have answer choices and they mention relative minimum, maximum, point of inflection, right? Well, f has a point of inflection if f double prime changes from positive to negative, right? Which means at the point, second derivative has to be equal to 0 or undefined, right? At x equal -1, second derivative is 2, positive 2, right? Then that means we do not have point of inflection at x equal -1. So C is not true, right? Now let's look at answer choices A and B. Does f have a relative minimum or maximum at x equal -1? Here, at x equal -1, f prime is equal to 0. Slope is equal to 0, right? F double prime is positive. Then f is concave up, right? Using the second derivative test, here, second derivative test says that, number 1, if f prime, let's say A, is equal to 0 and f double prime A is positive, then think about the graph of f. You know, it's concave up, and slope is 0, right? Slope is equal to 0. Then we will have relative minimum at this point, right? So let's say here's the x-axis, here's the y-axis, and this point is A. Number 2, if f, let's say f prime B is equal to 0 and f double prime of B is negative, then what happens? Since f double prime is negative, the graph of f is concave down, right? And slope is 0. Slope is 0. Then we have a relative maximum at x equal B, right? Does that make sense? So that's the second derivative test. So here we have f prime is equal to 0 at x equal -1 and f double prime is positive at x equal -1, right? apple prime is 0, apple double prime is positive, then it is concave up, slope is 0. We'll have minimum at this point, right? So we have, f has relative minimum at x equal -1. So the answer has to be A. Question 298. Suppose the function f is twice differentiable and the table above gives the selected values of f, apple prime, and apple double prime. Which of the following statement is true? Okay, we have 3 statements to think about. First one says f is decreasing in this interval, concave up in this interval, and a point of inflection at x equal 3, right? Here, is f decreasing in this interval from 3 to 5? Well, if f is increasing, then f prime must be negative in this interval, right? In the interval from 3 to 5. So let's look at this value right here. If we look at these two values, when x is 3, apple prime is negative. And when x is 5, apple prime is -2. Both are negative, right? But we don't know what happens between these two values. Let's say we could have at x equal 3.5, we could have a positive y prime. Let's say y prime is 2 or whatever, right? At 4.2, we could have a positive y prime, apple prime, right? Let's say 3 here, right? So we're not sure. We can say that in this interval, apple prime is always negative, right? So this statement is not true, not always true. Okay, does that make sense? Okay, second part. F is concave up in this interval right here. Okay, this one too. From 2 to 3, when x is 2, apple double prime is positive. When x is 3, 0, right? But between 2 and 3, we don't know what the values of apple prime are, right? Let's say when x is 2.5, we could have negative f double prime. Let's say -1, right? Then f double prime is not concave up at this point, right? So we don't know what values we have between 2 and 3. So we cannot conclude that f is always concave up in this interval. Does that make sense? So this one is not true. Okay? Okay, third part. F has a point of inflection at x equal 3. When x is equal to 3, f double prime is equal to 0. We have a point of inflection whenever f double prime changes its sign from positive to negative or negative to positive, right? It looks like it changes from positive to negative, but we don't know what. Here, let me draw the line. I'll show you. When x is 2, f double prime is positive. Let's say positive 3 here. When x is 3, let's say here's a 3, here is a 4, it is a 0 here. And when x is 4, it's a -2 here. Okay? But we don't know between 2 and 3, and 3 and 4, right? We could have this type of graph, f double prime, like this, right? Then at this point right here, f double prime is negative here, right? And negative here, right? Then this is not gonna be point of inflection. Do you guys see what I'm trying to say? So we don't know what happens between these two values and these two values, right? Before 3, it's not always equal to positive. after 3, it's not always equal to negative. Do you guys see that? So we cannot conclude that this is a point of inflection. Okay? So this is not also true. So the answer for question 298 must be A. Okay?